Morning, Algebra 2 nerds, and welcome to the last lesson in chapter, whatever we're in, 2, I think. Chapter 2, yeah. Today's sign is brought to you by Mr. William Bunn. Thank you so much, my good dude. Algebra 2 nerds. See these little 3D lines and stuff? I like it. It's nerds casting shadows. Today's lesson is, what's a good word for it? Tedious. Tedious is a good word for it. Not difficult material, but you have to be extremely careful while you're working to not make mistakes in symbols, not make mistakes in addition, subtraction, multiplication. There's just a billion steps that you have to make sure. You just have to make sure you do it right. Because you see the amount of space I gave you for this one question? That whole half sheet of paper like that? It's still going to be tight. Don't write large. I'm going to color code my notes for a very special reason you'll see here in a minute. If you're not color coding, you're going to want to number your equations as you go. We're looking at equations 1, 2, and 3 right here, which I'll number in just a moment. When you do these kinds of questions, realize they're going to take you several minutes per question. Accurate is more important than fast. In fact, the best way to be fast with these is to be extremely accurate. Accurate is fast. Fast is not accurate. We are going to be accurate. We're going to double and triple check everything we do while we do it, because it would really stink if you got through 5 minutes worth of math just to know that you messed up somewhere and you have to go back and redo it all. We are going to be solving systems of equations in 3 variables, an x, a y, and a z, so 3-dimensional lines, and we're trying to figure out where 3-dimensional lines would all intersect in one point in space. Our answer will not be a coordinate pair, it'll be a coordinate triple, and x, y, z. Goes alphabetical order. And we're going to solve these questions the same way that we solved the same ones that we did just a couple lessons ago that only had 2 variables. We're going to solve them the same way. Elimination or substitution. Actually, we're just going to use elimination. I'm not going to use any substitution for this because, yuck, it's not worth it. We're going to use a lot of elimination. But you think about Mr. M, there's 3 variables. I can't just eliminate 2 of the variables at the very beginning and I go, you're right. But what we can do is we can eliminate 1 variable. We can eliminate 1 variable at a time. So if we chose to eliminate 1 variable, we'd be down to 2 variables, right? And then once we had 2 variables, we could eliminate 1 of those 2 variables like we did a few lessons ago. So it's the exact same skill set being used in a new way. I'm going to start off by numbering my equations 1, 2, and 3. And I'm going to decide at the very beginning which variable would I like to eliminate. It really doesn't matter. You could pick whichever one you want, but it's always best to go for whatever's easy. And how do you know something is an easy variable to eliminate? It'll have a 1 in front of it. So that one right there, that's going to be our victim. So we are going to eliminate y. We're going to use the y in equation 3 to eliminate the y from equation 1 and the y from equation 2. So I'm only writing that for good note-taking purposes so you know what we did when you go home. Do you need to write 1 and 3? No. I know that I'm going to use equation 3 to eliminate the y's from these 2. So here's equation 1. Being very careful to make sure we wrote it down correct. And here's equation 3. Cool. We're also going to work with equation 2 and 3. because we're using the y's in equation 3 to get rid of the y's in 1 and 2. See, being very methodical, I'm checking every term as I write it, make sure I wrote the term correct, make sure my symbols are right. There it is. Okay. So what we're going to do is we're going to treat these as two completely separate things for now. In this first elimination here, I know I'm trying to make my y's match. In period 1, I had a request I asked, and only one person answered me, so I went with what that one person wanted. The request was to have the y's have opposite symbols so we can just add every time. And I said, I mean, fine. If you want to do it that way, it is what it is. This is a 1 in front of it, but it can easily become a 2. All I have to do is distribute a 2 across this equation. But if you want to just be able to add straight down, and you don't want to have to worry about subtracting negatives and things like that, you're going to want to distribute a -2, because then this one will be -2 and this will be +2. So that's what we'll do. We'll distribute a -2 to this bottom equation. But in this setup over here, one of them is a positive, one of them is a negative already. So I just need to make the digit match. This is a 3. This will become a 3 if I distribute a 3 across it. A little bit of arrow action for you. These two equations, I'm going to do their work in green. The top equation was unaffected, 4x minus 2y plus 3z equals -20. Again, double check, triple check if you need to. Make sure everything you wrote is correct. You don't want to have any accidental, oops, I missed a negative sign somewheres, because those will really upset you. You're going to burn up a lot of erasers if you're not super duper careful. The bottom equation, I need to distribute a -2. You don't need to hear me saying it because you're probably working on your own in your head, but I do point every time because it's going to help me see when my symbols are going to go between positive and negative. And if you see me make a mistake, please say something, because I can't erase all of my work. It's in pen. Cool. Those two equations have matching y's, one positive, one negative. How do I combine -2 and +2 to get a 0? Do I add or subtract? Add. Good. So we will add straight down here, and we will get a green equation that has no y's in it. 4 and 6 gets me 10. 3 and -4 gets me -1. -20 and 14 gets me -6. We have successfully eliminated y from those two equations. We only have two variables there. We're going to do the same thing, but with these now. The top equation was unaffected. Distributed 3 across the bottom one. Again, make sure everything is right before you move on. Looks good. One of my y's is positive, one of my y's is negative, so just like we had here in the green, I will have to add straight down to cancel. So 2 and -9 gets me -7x. Negative 4 and 6 gets me positive 2z. 20 and negative 21 gets me negative 1. So we've reached our first stopping point where I can go, would you like to ask me any questions at all before I go any further? Anything at all? Nothing. Okay. I now have two equations with two variables, just like we had a couple lessons ago. So what do? We stack them, we try to make a variable match, and we eliminate it, just like we did a couple lessons ago. It doesn't matter which one you put on top. It also doesn't matter which variable you choose to get rid of. Just pick one. One of them is easier than the other, though. Because again, if a variable has a 1 in front of it, your life is good. It's going to be very easy to make it match something else. This z will be very easy to eliminate from these two equations because one of them has a 1 in front of it. So I am going to make the z's match. This one's already positive, this one's already negative. I just need the same digit in front. That means I need to distribute a 2 to this top equation. Once the 2 has been distributed, that top equation will be 20x minus 2c equals negative 12. We didn't do anything in the bottom of the equation. And then add straight down because one of the z's is positive and one of the z's is negative. (20 and negative 7 gets us positive 13x. The z's are gone. Negative 12 and negative 1 gets us negative 13. And we can get x by dividing both sides by 13. X is negative 1. Yay, we know x. A couple lessons ago, once we solved for one of our variables, we picked an equation to plug it back into to get the other variable. Okay, well, we got to be really careful about this because there's equations all over this page. I have an x. So what I want to do is I want to plug it into an equation that only has two variables. One of those variables is an x. That way I can get the other variable alone. That means I need to come to one of these two, either the green or the purple. They have x's and z's. It doesn't matter which one you choose, but you drop x equals negative 1 into it and solve for z. I'm going to go with this purple one, just because. We found out that x was negative 1. Negative 7 and negative 1 gets me positive 7. Just going to subtract this 7 from both sides, and then I will divide by 2, and we'll have y. I said y, but I meant z. My apologies. We have x and z. Yay! And now that we have two of our three variables, we could take these two values and go up to one of the original three equations. It doesn't matter which one you pick. Put in the value for x and z that you found and get y all by itself. So I'll just go to equation 1 because why not? Four times whatever x is, I don't know y yet, plus 3 times whatever z is, and I'll get negative 20 when it's all said and done. the negative 4 and the negative 12 are on the same side of the equal sign, so they're like terms. I just combine them. Negative 4 and negative 12 is negative 16. You know what to do from here. Now, unfortunately, I kind of cut into the space for that second question, so math is going to have to get a little bit tighter on that one. But we got all three of our letters. There they are in frame. Now, like I said, this is going to be a point in space where all three things cross. So our answer is an x, comma, y, comma, z as an ordered triple instead of an ordered pair. Negative 1, comma, 2, comma, negative 4. There it is. I will not say that these questions are fast. No, they're not. They're very slow. And there's so many places that we could have just, oops. And we won't know until we get a ridiculous fraction somewhere or a nasty decimal somewhere. So just take your time. Be accurate. There. Separating my questions from one another. Before we move on, would you like to ask me any procedural style questions or what ifs or could I haves or any of that stuff? Yes, sir. Nope, it doesn't. You can choose any variable that you'd like. I basically just go whichever one's easiest. Because at the end, you're going to get the same results. And then as long as you put it in X, Y, Z order, you're fine. So no, you can choose whichever letter you want. Yep. For example, in this next one, on this next one, I could get rid of Y again because it's got a 1 in front of it, but I'll choose to go with Z instead just to show you that it doesn't matter what letter. Gavin, what's up? Is it possible to get infinite answers? Yes. It's also possible to get no solutions. And it happens the exact same way that you're used to. If ever during the process you get a true math statement with no more variables, infinite solutions. And if ever during the process you get a false statement with no more variables, no solutions. Yep. 100%. I'm not going to do that to you just because I don't have a reason to. Honestly, these kinds of questions, we show you that it's possible to do it this way, but the way that I'm solving these is not the preferred method. The preferred method is something that you might learn in AP pre-calculus, and that's if whoever the teacher is, me or Miss Stinson, decides to teach it. Just because, I mean, honestly, nobody does these the way we're doing them. You could, obviously, but it's not the most efficient way. But the other way is an entirely different branch of mathematics, matrix algebra. So a hand went up and then it went instantly down on my right. Where'd it go? Nobody? Okay, well, then let's move on. And like I said, because I see there's a 1 in front of Y, I could get rid of Y again. But I'll change it up because I don't want anybody to think that you always have to get rid of Y first, because that's what some students will think. So for this one, I see that my Z's have a 1 in front of them also. I'm going to go ahead and get rid of Z. I will eliminate Z. So we're going to kill off Z. I'm going to label my equations 1, 2, and 3 again. For this one, I'm going to be using equation 1 to eliminate the Z's from equation 2 and equation 3. There. Just trying to keep it all organized for myself. Equation 1. And equation 2. I would like my Z's to match. But they're both negative right now. And I know that my students prefer that if one is positive and one is negative, because then they can just add. Fine. Then I'll distribute a -3 to the top equation. That'll make the z's match for that one. For 1 and 3, well, they have different symbols already. One's a positive, one's a negative. Yeah, what's up, Nick? No. Oh, you could, yeah, I just put it on top because 1 comes before 2, but no, it doesn't matter at all. 100% won't make a difference. The only thing that might change is our equations might look different. Like mine might be the negative version of yours, but that won't make a difference in the end. Since my z's already have opposite symbols, I just need them to have the same digit. This one's got a 1 in front. It'd be nice if it had a 2, so I'm going to distribute a 2 across the top equation for that one. Going to distribute that -3 now. Be really careful, methodical. And also, please don't hesitate to tell me if I did something wrong. I got really close to the edge of my paper. My z's match. One's positive, one's negative. So I can add straight down. To finish up this green math, -9 and -4 gets me -13. 3 and -2 gets me +1. -39 and 1 gets me -38. I have eliminated z from the first 2 equations. Oh, I just realized I'm missing somebody in the back. Pause this while I do it. And for the second one now, we're going to go ahead and distribute a 2 across that top. Bottom one was unchanged. And just like before, one of my 2 z's is positive, the other is negative, so I can add straight down to get rid of them. Six and 5 makes 11. -2 and 3 makes +1. 26 and 8 makes 34. And look, this is a gift. These 2 y's have the same number in front of them already. So it's going to be very easy to eliminate y now when we go to this next step. But one of them doesn't have a minus and the other has a plus. So since they're both +1, am I going to add or am I going to subtract? Lots of people could shout it out because I know you all know. It's subtract. Yeah, 1 + 1 is not 0. So I am going to have to subtract straight down this time, being very careful with my negatives. -13 and -11 gets me -24. -38 minus 34, or you could say -38 and -34 gets me -72. I've run out of vertical space, but you're going to divide by -24. X is 3. When you divide both sides by -24, you will get x equals 3. Now that you know x, just like before, you take it to one of your two equations that only has two variables in it, and you drop it in there. So we're going to take it to this green or this purple. It doesn't matter which one we choose. We're going to toss x equals 3 into there, and we're going to solve for y. I'm going to go with the purple one again, just because it's looking like easier numbers and everything will stay positive. Where do I have space? Way up here. 11 times whatever x was plus y equals 34. And of course, we got x was 3. So check this out. It tells us that 33 plus y is 34. Look how easy it was to get y alone. Y is 1. I know x, I know y, I have two of the variables. I take my two variables to one of the three equations, and no, it doesn't matter which one you choose. You throw x and y into it, you get z all by itself, and you put a bow on this question. And it doesn't matter which one you choose. Anybody have any preference? First one? Okay, why not? So we'll go to the first one. 3 times whatever x is minus whatever y is minus z is 13. We found that x was 3. We got that y was 1. And we'll go to town. Nine minus 1 is 8. Subtract 8 and divide by -1. Remember just to put your answers in XYZ format. In ordered triple. Ta-da! Are they quick? No. Are they difficult? I don't think so. There's a lot of steps, there's a lot of pieces, but that doesn't make a question difficult. I mean, we really didn't have to do any mental gymnastics to pull this off. It's just elimination. Now, if you had 4 variables and I was making you do it by hand, that would be terrible. And yes, you could, but man, we won't. What do you think? Can you pull this off? So on the back is a word problem, everybody's favorite. But once the equations are written, it's exactly the same as the stuff that was on the front. As usual, writing the equations correctly is going to be the hardest part about word problems. I started writing your chapter test last night. I wrote down and word problems at least 4 times on the skills that we've learned. So, let's go make sure that we can do word problems. 3 different families go to eat at a burger place. The first family buys 4 burgers, 3 fries, and 4 drinks for a total of $28. I feel like my 3 variables were just chosen for me. There they are. Burgers will be X, fries will be Y, drinks will be Z. Nope, doesn't matter which one you choose to be what. The only thing that matters is at the end of the question, you definitely want to have your variables defined, because what if on my test this multiple choice question just says, what is the cost of a burger? Then I'm not looking for the X, Y, Z. I'm looking, for me, it would be just for X. So if burgers are Y for you, that's fine. You just have to make sure that you know at the end you were looking for a Y value, something like that. So let's write these 3 equations. The prices of things are rates, and I think I've driven it home by now that a rate always belongs in front of its corresponding variable. So their first equation is going to be 4x plus 3y plus 4z equals 28. The second family buys 6 burgers, 2 fries, and 3 drinks. They spend $32.50. 6x plus 2y plus 3z equals 32.5. You don't need to put the 0 on the end. And the last family, 5 burgers, 5 fries, 5x plus 5y, 6 drinks for $39. Now, the hardest part of the word problem is done. But we do have to do all the same work again that we did on the front. Nothing's new though, it's all the same stuff. You just have to pick a letter to eliminate. And it doesn't matter which one you choose. Anybody have a preference? Somebody said y? All right, let's get rid of the y's first. It really doesn't matter. He says z would be so much easier. Why do you think z would be easier? What he's trying to say is because right here, if we did z's, this number could become a 6 really easily because they have a common factor. But it doesn't matter. That's the good news. Someone said y, so we're going to go after y's. And again, it doesn't matter which one I choose to cancel the other two. That is also arbitrary. So I'm just going to use the one with the smallest y to be the one that works on the other two. So that means I'll do 1 with 2, and I'll do 2 with 3. So I'm going to use this y to get rid of the other two y's. All right. 1. And 2. I'll go ahead and write 2 and 3 while I'm holding this black pen. All right, so we are going to try to go ahead and get rid of the y's. For these first two, the numbers 2 and 3 on front of my y's have nothing in common. We have to make the match using multiplication. The smallest number that both 2 and 3 could become is a 6. Now I know that you guys like it when one of them is positive and one of them is negative, so just pick one to be negative. Who cares which one? Unimportant. I'll multiply the top equation by 2. So I'll have a 6 in front of my y's. I'll multiply the bottom one by -3. So I'll have a -6 in front of those y's. As I know that that's what you guys prefer. Over here, same idea. A 2 and a 5 have nothing in common. The smallest number that they can both become is a 10. But they're both positive. I know that you guys like it when one of them is negative. So I'll multiply the top equation by 5. So I'll have a positive 10 in front of that y. But I'll multiply the bottom equation by -2 to put a -10 in front of that y. And let's go ahead and rewrite these. Distributing a 2 gets me 8x plus 6y plus 8z equals 56. Second equation, distributing that -3, -18x minus 6y minus 9z is, -97.5 Yuck. Since one's a positive 6y and the other's a minus 6y, we will add straight down to cancel. Eight and negative 18 gets me negative 10. 6 and negative 6 is 0. 8 and negative 9 is negative 1. 56 and negative 97.5 is 41.5, negative 41.5. Anybody tested on their calculator already? Is negative 41.5? Okay. All right. Purple. Distributing a 5 across the top is going to get me 30x plus 10y plus 15z equals, 162.5. Yep. Distributing in negative 2, negative 10x minus 10y minus 12z equals negative 78. But since one of my 10y's is positive and the other is negative, I can add straight down. I have a 20x. 10 and negative 10 is 0. 15, I was going to say 152. 15 and negative 12 is 3. And I'm not even going to try. 84.5. Okay. There it is. We stack those two up and continue to eliminate. And we actually get to choose. Do we want to get rid of the x's or the z's? And it's not any easier to do one over the other. I'm going to get rid of the x's because I can multiply 41.5 by 2 relatively easy in my head, but by 3 would slow me down. So I am going to multiply the top equation by 2. That way one of them says negative 20x and the other one says positive 20x. And since I have all this lovely vertical space to work with, I'm just going to keep going down. One of my x's is positive, the other x is negative. Adding straight down. It's going to cancel those. Negative 2 and positive 3 gets me 1z. And negative 83 plus 84 is positive 1.5. We just found out that our drinks cost $1.50 each. There you go. Take your z up to either one of the either green or purple equations. I'm going to go with this one, just so I don't have to multiply 1.5 by anything. And what I see is that I'm going to get a negative 10x minus 1.5 equals negative 41.5. Start getting x by itself. Add 1.5 to both sides. negative 10x is equal to negative 40. Dividing both sides by negative 10 will give us the price of a burger. $4. So we have $4 burgers, $1.50 drinks. We take our x and our z up to one of the three original equations. It doesn't matter which one. I'm going to go with equation 1, and we drop in the two variables that we know. So we have 4 times whatever x equals, plus 3y, plus 4 times whatever z equals is equal to $28. We found x to be 4, and we found z to be 1.5. 4 times 4 is 16. 4 times 1.5 is 6. This 6 and this 16 are on the same side of the equal sign. They are like terms. 6 plus 16 is 22. Now get y alone. As an ordered triple, it goes 4, 2, 1.5. For burgers, fries, drinks. Wow. Thanks, nerds.